guys, so we are moving on to Module 15, and what we're looking at in Module 15 is essentially how to solve equations when there are variables on both sides. But the really cool thing is that knowing that we just came off of graphing y equals mx plus b equations, what we're really doing is looking at two y equals mx plus b equations. And we're asking a question about those equations. So before I move on to these notes, I want to kind of look at the backstory based on what we know, okay? So we know that we've got y equals mx plus b, m is our slope, and b is our y-intercept. We already know that, okay? And if I have two of these linear equations, I can put them both on a graph. Really, when I am solving for an equation with the variable on both sides, what I'm really asking is this question: where do these two lines intersect? Okay? All of our problems are going to intersect at some point. And so really, by solving for the equations, by setting them equal to each other, we're asking, where do they intersect? I want you to notice something. By setting them equal to each other, we are assuming that the y is the same thing. In other words, if I took this mx plus b and said it was equal to y, and these y's are the same thing, then this mx plus b can be set equal to this mx plus b. Well, if their y values are the same on our graph, then by solving for x, we get an x value. And we know that when we have an x value and a y value, it will give us a point. So essentially, by doing this, I will find the point where these two lines are going to cross over each other, okay? So for instance, if we were just eyeballing this, if this was, let's say, 2x plus 5, okay, we could say, well, let's see, that's about here, here's about 5, and it's gonna increase sort of at this rate, okay? And then if I said that this guy was, let's say, 5x plus 1, well, now we're just here at 1, but I'm going to increase at a faster rate. Boom. Then this point right here is going to represent where they cross, okay? And we will be calculating for the x value and the y value, right? That's essentially what we're going to be doing in each of these problems, okay? So let's flip back over and take a look at our first sample problem. We have 7x plus 2 equals 4x plus 17, all right? And really our goal here is we want to put the x terms on one side, and we want to put the non-x terms on the other side, okay? And we know that we can do that with some of our algebra tricks. So I'm going to start with the x's. If I add a negative 4x to this side, that will wipe this out. And if I have to add a negative 4x to this side, then I've got to do the same thing over here. Now you might be wondering, well, why didn't I add a negative 7x to both sides? I can. It's just that if possible, I want to try to combine these x's so that my result is a positive number. Okay, so I'm going to go ahead and add a negative 4x here and add a negative 4x here. We know that 4x plus a negative 4x is 0, and I'm left with 17. And then we know that 7x plus negative 4x is 3x. All right, so I'm almost there. At this point, it really looks like I've just got a two-step equation, and we know what to do with two-step equations. The next thing I'm going to do is get rid of this 2 by adding a negative 2 to both sides. And now I have 3x equals 15. And of course, the last thing I'm going to do to get x by itself, divide by 3, and x is equal to 5. Okay? So what's really neat about this is I already know my x value. And keep in mind, when I go back to graph these, I need an x value and a y value in order to graph. Well, where do we get my y value? Well, we get my y value from plugging this back into my original equation. So 7x plus 2 equals 4x plus 17. Well, now I know that x is 5. So 7 times 5 plus 2 is equal to 4 times 5 plus 17. Then this just becomes simple basic calculation. We've done these since the beginning of the year. 7 times 5 is 35 plus 2. 4 times 5 is 20 plus 17. And if we've calculated correctly, then we should have that 37 equals 37, which it does. This is my y value. Okay? So my point of intersection is 537. All right? And if I were to go ahead and go back in and graph these two lines, graph y equals 7x plus 2 and y equals 4x plus 17, if I were to graph these two on a grid, this would be the point where they would intersect, where they would cross over each other, okay? All right, let's try the next one. So I've got negative 2x plus 19 equals 3x minus 1. Notice negative 2x means that if I were to graph this line, it would have a negative slope. This one has a positive slope. Notice this first one starts or crosses the y-axis all the way up at 19, whereas the second one crosses the y-axis under the origin at negative 1. Okay, so kind of keep those things in mind. You know, if I was going to sketch these out over here, it might look something like this and this. Okay, that's kind of a rough sketch of what that might look like. So let's go ahead and solve. Now, if I add a negative 3x to both of these sides, I'm going to end up with negative x's over here, and I'd love to avoid that if possible. So instead, I'm going to add 2x and add 2x. I now have 19 equals 5x minus 1. Our goal is to have x's on one side and non-x's on the other side. So let's move this negative 1 so that we can keep the x by itself. Add 1, 20 equals 5x. Divide by 5, and 4 equals x. So there's our first point. Okay? Well, remember, where do we get our y? We're going to actually take 4 and plug it back in up here to x. So negative 2x plus 19 equals 3x minus 1. Negative 2, we've said that x is 4. Negative 2 times 4 plus 19 equals 3 times 4 minus 1. Well, let's see. Negative 2 times a positive 4 is a negative 8. 3 times 4 is 12. And look at this. 12 minus 1 is 11. Negative 8 plus 19, which is the same as 19 minus 8, is also 11. So there's my y value. Okay? My point of intersection is 4, 11. That's where they're going to cross over with each other. Okay. Now, it really doesn't get much more complex than that in your practice problems today, but I do want to look at one other little curveball that might be thrown your way, okay? We're still looking for where both of these cross each other, but notice they're not quite in mx plus b form yet, okay? What's that property that we've got to use in order to put these in mx plus b format? Notice we've got to distribute first, okay? So this is kind of taking a lot of our skills from the year and putting them all together. When I distribute here, I'm going to have 5x plus 10 is equal to 3x plus 24. Now we're in business again. We've got 5x plus 10. we've got 3x plus 24. Notice both of these have a positive slope. Both of them cross the y-intercept above the origin, okay? So let's go ahead and figure out where they cross each other. I've got a 5x and a 3x, so let's go ahead and join these together over here. Plus a negative 3x, plus a negative 3x. I'm going to be left with 2x plus 10 is equal to 24. Well, if we moved my x's to the left side, let's move my non-x's to the right side. Minus 10, or plus a negative 10 gives me 2x equals 14. Divide by 2, x is equal to 7, right? So we're halfway there. We want to get that y, the y coordinate. So I'm going to come back up here. 5x plus 10 equals 3x plus 24. 5 times 7 plus 10 equals 3 times 7 plus 24. 35 plus 10 equals 21 plus 24. 45 equals 45. Now, one thing I want to point out is if you notice, I took my x value and plugged it back into my simplified equation. You could take your x value and plug it back in up here. That would be just fine. Notice what would happen here. I would have 5 times 7 plus 2 equals 3 times 7 plus 8. We're still going to simplify and end in the same place. 7 plus 2 is 9. 5 times 9 is 45. 7 plus 8 is 15. 15 times 3 is 45. So either way, we'll get to our 45, okay? And what's my point of intersection? It's 745. Right? Okay, last one. Now I've got my 10 minus x equals negative 34 minus 5x. Okay, if you want to rewrite this so that the mx plus b format is a little bit clearer, that's fine. You could do that. That was from our last quiz. Or you can just leave it as is, all right? Let's see. I'm going to go ahead and add 5x to this side and add 5x to this side. And look what happens here. I now have 10. And what's a negative? Remember, this is 1x. Plus a positive 5x, well, that leaves me with positive 4x equals negative 34. Okay, no problem. Then I'm going to add a negative 10 or subtract 10. That's the same thing. We have 4x equals negative 34 plus a negative 10 is negative 44. Oops, equal sign. Divide by 4. X is equal to a negative 44 divided by 4 is negative 11. Okay, so there's my first coordinate. Okay, then I'm going to come back in and plug it back in. I've got 10 minus x equals negative 34 minus 5x. And this is where we're really going to have to be careful with these signs. This is the reason I worked this one out. Notice this means 10 minus whatever x is. My x is a negative 11, so this really means 10 minus a negative 11. Negative 34 minus 5 times whatever x is, which is a negative 11. Okay, so this, again, this is really layering in a lot of our integer rules from the beginning of the year. 10 minus a negative 11 is the same as 10 plus a positive 11. Remember, subtraction is the same as adding the opposite. 10 plus 11 is 21. Then we get over to this guy. This is kind of crazy. Negative 34 minus, well, what's 5 times 11? 5 times 11 is negative 55. And negative 34 minus negative 55 is the same as negative 34 plus a positive 55. And then we get back to our 21. Okay, and my point of intersection is negative 11 positive 21. Okay, now after this video is over, you're going to click on a second little video and I'm going to show you the graphs of these on Desmos, and we're going to confirm that these point of intersections actually are true. But this is sort of the algebraic step that we're taking towards figuring out where these two linear equations cross each other on a graph. The practice on this is going to be repeating this process over and over again. So you guys have got this. If you've got any questions, let me know. Check out the next video that shows these on a graph, and then you'll be set to go for your lesson.